Okay, here we go. This was a test problem. You guys all bombed it tremendously bad. Bombed it.
Did you bring it right?
How about you listen, I teach? I did.
Oh, boy.
All of you. This one right here was a problem that was ridiculous. I gave you open book, open note, get them on. And you guys did not know anything in your textbook to be able to find the rules. In your notes, you clearly didn't read them enough to be able to find out where the rules were to be able to do this problem. And here's what is disturbing to me. The concept quiz, you all did very well on. This is the concept bite quiz. This is a problem from the concept bite, very similar to it. You guys did great on that quiz, which would tell me as a teacher that you guys understood the section. But yet, when you gave you the text, you never looked at it again to make sure that you remembered the section. Do you understand what I'm saying? So tell me honestly, how many people in here actually studied? You cannot expect to do well at something if you don't study and put the time into it. You can't. I'm not trying to be mean, I'm not trying to be disrespectful. I am tired of giving my time to people who refuse to put any time outside of the 40 minutes that I have you to be successful in this class. I'm not trying to be mean, but you have got to put more time into it. I will fail you. Because you are not earning the grade that you deserve. Do you understand me? Now, what do I do here?
Just give me -2.
You gotta put the missing exponents. That's the first thing you guys messed up on. Half of you forgot to put the exponents on the 3 and on the 2. Aww. So whenever you then went and said, well, you gotta multiply, you didn't get 3 to the -2. Don't know what number that was. And you didn't get 2 to the -2. But many of you did get the U and the V. You did well on that part.
So close.
You've heard me say this many times. Numbers, letters, with letters. Numbers, letters, with letters, right? Yeah. Well, my numbers. Here's my fraction. 3 to the -2. I've talked about that red poster. I don't know how many times. And it says, if you have a negative exponent in the top, to get rid of it, it goes where? To the bottom. It becomes positive. If I have a negative exponent in the bottom, to make it positive, I move it to the top. Tell me why you didn't do that.
I did.
Now, the next thing your brain needed to understand is the green poster over there by Trish. If I have u to the 8th over u to the 10th, how are those two bases that are the same attached? Division. So what do I do with my exponents according to that? You subtract. When do you add the exponents?
They are side by side.
When they're attached by multiplication. So you subtract these exponents.
You're left with 2 on the bottom.
So what is 2 squared? That again you did not finish. What is 2 squared? 4. What is 3 squared? 9. And 8 minus 10 is?
-2.
And -6 plus 2 gives me? -4. Right there's a mistake for many of you. Now guess what? Make it a fraction. Put it over 1. I have one big fraction, the 9 stays at the bottom, the 4 stays on the top. What stays and what goes?
Both
Go to the bottom. Now tell me why, whenever I walk through this problem with you right now, that you all get that. I can't remember if I read that down. Was it as hard as what you thought it was?
See all the numbers and letters.
I think it was just because of that.
On the outside? Looks scarier on its head. It may look scary, but guys, the rules are still the rules. You take it step by step. You have to work from left to right. If you work from left to right instead of hopping and bobbing around and letting your eyes go back and forth between what you think is ugly and what you think is okay, you'll be fine then. You have to take it from left to right and not freak out. Once you've gone from left to right, you don't look back because you're already done with it. You know you can handle it, right? If you recall, whenever I worked this problem, I started from left on the top and then from left to right on the bottom. Did you see how I did that? I did top to bottom, left to right. You with me? And I didn't look back anytime, did I? You have to think about that. The other thing that many of you sucked at. What is 5 divided by 5?
Yes.
What is x divided by x? divided by x to the 24th.
1. I got that one.
What is x to the 0 power? It was on the test. And many of you did not get that. And I said, back poster, red poster, anything to the 0 power is always and forever 1. Even if you missed this vote completely, where the top was the same as the bottom, you should have still subtracted these exponents to get a power of 0. And if you got a power of 0, then you should have known that the answer is going to be 1. And that's not anything that I can teach you. It's something your brain needs to memorize and your brain needs to recognize. Do you get that? I can tell you until I'm blue in the face, but you guys have to acknowledge that property and get it and commit it to memory. Do you understand that?
Do we get our test back?
No. What's going to happen is you're going to take a retest.
Yeah.
Because it is like ridiculous. It is disgusting how bad it is.
Everybody?
It is disgusting how bad you get it. If I'm looking at this,
Where's the mouse? Found it.
and hit the red button.
Which red button?
I'm recording now. It's okay.
Here it is.
Now, chapter 6.4, rational exponents. A rational number is any number in the form of a fraction. For example, 1/3. 1/3 is decimal form, 0.3 repeating.
How many points did they got for that?
Another rational fraction would be 1/2, which is going to be 0.5. 0.5 is the terminating decimal. So what I'm telling you is that a rational number is any fraction or any decimal that's repeating or terminating. Power over root. You've heard me talk about power over root before. Power is going to be the number that's attached to the base as the small number in the right-hand corner. It's your exponent. Your root goes in, it's the number that goes inside the check mark, your root symbol. This is also known as your index. Index and root are the same thing. Index and root are the same thing. Now let's say I had a negative exponent. Let's say my power was negative 2/3. You do not put the negative with the root. The root must always stay positive. Okay? So instead of having a negative 2/3 being in the middle, you're going to put the negative up top with the numerator, not with the bottom in the root. The root always stays positive. The root always stays positive. Do we all understand that? Now, tonight's assignment is extremely simple. I'm not making that up. It is not a hard worksheet at all. What I want you to do is be able to go from the fourth root of x cubed, written in this form, to writing it as an exponential base, I should say a base with an exponential power, meaning a fractional power. So how do I write that? Power over root. What's my base?
X.
My base is x. What's my power?
4.
Power. 3.
3.
What's my index?
4.
There's your done. There's your answer. X is 3/4.
Why can't we use it?
Because she doesn't like numbers.
Seventh root of w to the 5th.
W.
What's my base?
W.
W to the what?
5/7.
5/7.
And whenever we do that, if it comes to it, do we reduce?
If it's reducible, you want to reduce it, yes, every time. Now we're going to go backwards. Y to the 7/8.
So the 8th root of y to the
Trevor, excellent job. The 8th root of y to the 7th. That is excellent the way you said it. Very proud of you. U to the 2/3 power.
the 3rd root cube root.
The cube root of u squared. Of u squared.
That's all we're doing?
We're not done. I'm going to do homework problems with you, but we're going to do the
I
worksheet.
meant like that's all that's on the homework.
This is about as easy as it can be for you today. I need to make sure that your brain has mastered this before we can go on. If you can't go back and forth between these two forms, then the whole entire section is going to be jacked up. Do we all understand what I just said? So, with that said, here we go. Number 1, what does the directions say? Write each expression in radical form. Radical form means I better see my nice little root symbol. So how do I write this?
Cube root of X to the fourth.
This is the cube root of x to the fourth. Index goes in, the 3 is the index, goes in the little check mark symbol, the root symbol, and my power is my 4, it goes up onto the base. What about a to the 1.5? That's not a fractional exponent, is it?
No.
So make it 1. That's going to make that a to the 1.5. What is a to the 1.5?
3 seconds. 3 seconds.
And I'm going to back this up because I don't want to have to explain myself again. What position is 5 in?
10.
The tenths. I am showing you this not because I know that you guys don't know that a half is 0.5. I know you know that, but for another example later on the problem, I don't know why, but you guys just get all jacked up. So what's 5 over 10 reduced down to? 1/2. Use the C rule. 2 times 1 is 2, plus 1 is?
3.
Remember that? 2 times 1 is 2, plus 1 is 3 over 2. That's the C rule. I heard it. What? Now, what is that going to be? Nope.
Oh, square root of a
The
cube.
square root of a cube. Nope. Now, number 11. What's it say to do on number 11? Write each exponential form. So now we're going backwards, right? I give you the radical, now give me the power in exponential form. So, what's my base? And what's my power? 4 root is 5. N to the 4/5. Do we understand that? Number 10. What's my base on number 10? 6a. So we write down 6a. What's my power? 4 root 2 to give me 6a squared. 6a squared. What would that actually be?
You have to put that in parentheses.
Yes, you do have to put that in parentheses.
36 squared.
It would be 36a squared if I asked you to simplify completely, but I didn't. I just wanted a base with an exponent. We did that. Keep going. Number 14, what does the direction say there? Simplify each expression. So now I want it completely down to its simplified format. Smallest possible thing. What's this going to be? Square root of 64. Square root of 64, which is? 8.
Wouldn't the 2 on the top be the same thing as the square
The
root?
2 is what's inside here, and the 1 is what's there. They're understood to be there.
Okay.
Which means what you have going on here is a 2 there and a 1 there, and I don't need them. They can disappear completely, and they will. We all good on that, yes or no? Yes. Okay. 17. 17. What's my base? Negative 5. So the green poster over by Trish, what does that tell me? If I have one base, what do I do with my exponents when they're all attached to multiplication? You add them. So I'm going to take negative 5, 1/3 plus 1/3 plus 1/3. 1 plus 1 plus 1 is 3/3 to give me 1, which is just negative 5. The verse, which is just negative 5.
Wouldn't it be the same thing as negative cube root?
23.
12 times 45 times 50.
Nope, I can't add them.
You're back.
Are the bases the same?
Oh, no.
My bases are not the same, so you cannot add the exponents together. Do we all understand that? So what you're forced to do is what? Write them each as a cube root of 12 times the cube root of 45 times the cube root of 50. Now that they're all radicals with exactly the same index, what can I do?
Multiply.
I can marry them and write them all as one. So that's the cube root of 12 times 45 times 50. Do I have any perfect square or cube factors of 12, 45, and 50?
You got 3 and 4 for 12.
3 and 4. Perfect square or cube factors of 45. 9 times 5.
5 times 2.
And then 25 times 2. Why am I asking for cubed or squared? Because we want pairs, we want triplicates. Triplicates is what we want. But if we have a pair, then maybe I can get my triplicate with another one from another factor, right? Just like 4. How can I rewrite 4? I can rewrite 4 to become 2 squared. How can I rewrite 9? 3 squared times 5. How can I rewrite 25? Now, how many 3's do I have inside there? 3. Do you see how my pair for my 45 can now be paired with my lovely little 3 for my 12? And I can now have 3 3's, 3 2's, and 3 5's inside there.
One of each.
Yes, James. That's fine. Yeah. So this is going to give me 2 cubed, 3 cubed, times 5 cubed to give me what?
30.
2 times 3 times 5 to give me 30. I'm done. You guys have the rest of the period to finish this. The answers are up here if you'd like to check them whenever you're done. Does everybody have this one done? Does everybody have this one done?
Yeah.
There's the previous one that you've asked for.
I don't get how
The
you
bases are all the same, so I add 1/3 plus 1/3 plus 1/3 to give me 3 over 3, which is 1. Because it's -5 to the first power, with -5 to the first power. -5. You're fine.